So guys, welcome to our channel once again. In today's video on our JAMB Chemistry exam revision series, we have here these 10 practice questions to solve on energy changes. So guys, this video will be about entropy. So in short, stay till the end of this video. Also, if at any point you feel you want to answer any question, you can simply pause this video and try out to see if you can get the answer to the question even before we provide the answer thereafter. So with this said, let's go ahead and start with the first question here. That's question number 1 here. It says, an increase in entropy can best be illustrated by A. Solidifying candle wax, B. The condensation of vapor, C. Freezing of water, D. Mixing of gases. So guys, the answer to this question here is option D here, and that's mixing of gases. So entropy is a measure of the disorder or randomness of a system. So the mixing of gases actually results to an increase in this level of disorder. That's the entropy, because the gases actually become more disordered as they mix. So that's the answer to this question. Let's consider the next question, guys. That's question number 2 here. It says, dash is a property of a substance measured in joule per Kelvin per mole. So guys, here we have pressure, we have entropy, we have enthalpy of pressure, we have thermodynamic pressure. So guys, the answer to this question is option B here, and that's entropy. Entropy is a property of a substance measured in joule per Kelvin per mole. It's actually a measure of the degree of disorder of a substance, and it has these units. So guys, that's it. Let's quickly look at the next question, and that's question number 3 here. It says, which of the following reactions would be expressed to have the highest entropy change? A. Solid to liquid, B. Liquid to gas, C. Gas to liquid, D. Gas to solid. So guys, the answer to this question here will be option B, and that's liquid to gas. So we know that the phase change from a liquid to gas involves an increase in entropy. So in this phase change, molecules actually have higher degree of freedom and are more dispersed compared to that of the liquid phase and the rest. So that would be the answer to this question. As substances move to gaseous state, their entropy actually increases more compared to that of other phases. So guys, that's it with that question. Let's consider the next question. Question number 4 here. It says, dash is a measure of the disorder or randomness of a system. A. Gibbs free energy, B. Equilibrium, C. Entropy, D. Enthalpy. So guys, the answer to this question is option C here, and that's entropy. So let's consider the next question. Question number 5. So we have an equation of a reaction here, ammonia gas reacting with hydrochloric acid gas to yield ammonium chloride in solid. So the question here says the entropy change in the system above is A. Positive, B. 0, C. Negative, D. Indeterminable. So guys, the answer to this question is definitely option C, and that's negative, because the reaction actually went from gas phase to solid phase. So definitely there shouldn't be more of disorderliness. So the measure of the disorder or randomness in this reaction is actually going to be negative, since it's actually becoming more ordered into a solid form. I just hope you guys understand this. So that's the answer to this question here, guys, and it's option C, negative. So let's consider the next question. That's question number 6. It says here, which of the following hydrogen halides has the highest entropy value? A. Hydrogen fluoride, B. Hydrogen chloride, C. Hydrogen bromide, D. Hydrogen iodide. So guys, the answer to this question here will be option A. Hydrogen fluoride has the highest entropy value because density increase down the group for the halides. So that will be the answer to this question, option A. So let's look at the next question, question number 7. It says, in an endothermic reaction, if there is a loss in entropy, the reaction will A, be indeterminate, B, be spontaneous, C, be at equilibrium, D, not be spontaneous. So guys, in an endothermic reaction, if there is a loss in entropy, the reaction will not be spontaneous. So let's consider the next question, question number 8 here. It says, when a sugar is dissolved in tea, the reaction is always accompanied by A, positive entropy change, B, a minimum entropy change, C, no entropy change, D, negative entropy change. So guys, the answer to this question here is option A. It's actually accompanied by a positive entropy change. The dissociation of the sugar actually in tea is accompanied by a positive change in entropy. So guys, it makes sense because the sugar is actually dissociating and it's more like getting more disordered. So that would be a positive entropy change. So that's option A here. So let's consider the next question, question number 9. It says, in which of the following are water molecules in the most disorderly arrangement? So we have ice at negative 10 degrees Celsius, water at 100 degrees Celsius, ice at 0 degrees Celsius, and steam at 100 degrees Celsius. So guys, this will be option D here, since the steam at 100 degrees Celsius will actually produce vapor, which is gas. So in that case, the gaseous form will always be the most disorderly arranged form. So in this case, option D is the correct answer to this question. So that's it. Let's consider the next and the last question here, guys. That's question number 10. It says, if the change in free energy of a system is negative 899 joule per mole and the entropy change is 10 joule per mole per Kelvin at 25 degrees Celsius, calculate the enthalpy change. So guys, for this question here, we are simply going to zoom right into our workspace here and actually solve this together. So let's consider the equation that we'll always have for this. Delta G will be delta H minus T times delta S, where delta G is it gives free energy, delta H is the enthalpy change, and delta S is the entropy change, and then T here is the temperature. So guys, from the question, we've been given delta G to be negative 899. So this will be negative 899. But we don't have a delta H. But we have a T for the temperature, which is 25 degrees Celsius. So 25 degrees Celsius is actually 25 plus 273 Kelvin. So that will be 25 plus 273 is 298. So this will be 298 Kelvin. So remember that your temperature has to be in Kelvin. If you have a temperature in Celsius, in degrees Celsius rather, you have to convert it to Kelvin. So this will be multiplied by the entropy, which is 10 joules per mole per Kelvin. Alright, so with this here, we're going to have negative 899 is equal to delta H minus Now this multiplied by 10 is going to be this. So in order to make delta H the subject of the formula here, or the subject of this equation, we're going to have delta H to be negative 899. Then this over here is plus 2980. You can still rearrange this to be 2980 minus 899. So in any case, you're going to have delta H to be 2081 joule per mole. So guys, that's option A here, and that's the answer to this question. So let's go ahead and wipe this off, guys. So guys, this is where we'll end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not a subscriber. Also, if you have specific question regarding this video, you can drop your question on the comment section below and we'll ensure to give you a response. So guys, don't forget to also share this video with your friends to enable us reach out to more people around. And we want to also use this medium to encourage you to join our YouTube channel community by clicking on the join button below so that you can gain access to our premium information on JAMB updates. So guys, this will be very helpful to you even as you prepare for your JAMB examination. And guys, that will be all for this video. Thank you once again for watching this video. See you on the next one.